Good evening, everyone. Good evening, everyone. Welcome to Unacademy, India's largest online learning platform. Yeah, can you please comment in comment box so that I can understand your on live. Yeah. Good evening, Preetham. Good evening, Sri Charan, Sai Charan, Ravindra, Anjali, Vijay Kumar, Sandhya, Harish, Sridatta, Shivamani, Sridhar Kumar, Sudhir Khanna. Welcome to the next session of our electronic devices. So, as we discussed earlier, today is our second class. In the last class, what we discussed is we have seen the overview of the subject. We have discussed only overview of the subject. Arvind, Anuradha, Jashwant, Gayatri, welcome. Good evening, good evening. Good evening, everybody. Yeah. So, moving on to the original topics for this electronic devices. Okay, so this is going to be second lecture. That is the first lecture we have discussed only the overview of the subject. Now this first topic is going to be semiconductors physics. In semiconductor physics also we are going to discuss something called the most important topic. The first topic is going to be atomic structure. Atomic structure is what we are going to discuss. Okay. So once again, those who are new for the first time coming online, Hepsi, good evening. Chaitanya Reddy, good evening. So, myself, H. Shravan Kumar, having 10 years of teaching experience in various engineering colleges, and I have a master's degree from JNTU Hyderabad in VLSS system design. And I have mentored many people, many students for GATE and ESE. So, again, my areas of interest are EDC. This is a subject which we are discussing right now. And I am also comfortable with analog electronics, digital electronics, and I'm okay with EMFT also. Right? First, we will finish this entire syllabus of EDC, then we'll go to the other subjects eventually in coming days. Right? So, as I told you, my target is for those who are in third year, that is 2022 GATE is the major important thing for me. Okay. Venkat Naidu, good evening. Okay, now moving on. So as Unacademy has its own app to access many classes, not just my classes. To access many classes, you are required to download the Unacademy app. You are required to download the Unacademy app. So it's very simple, as you do many downloads of apps. So it is also one of the simple app, and just 2 minutes. It will take just 2 minutes, sir, to download and do everything. So the first step is just go to the Play Store and type Unacademy Learning App. Unacademy Learning App. So in the search box you'll get it. So you'll see this kind of figure. So click on install. Click on install. Once you get installed, then you'll go to the step number 3. So this is the most important, sir. That is selecting your goal. Selecting your goal. Whether you are a student of UGC NET, CSIR UGC NET, so TNPSC, everything, IIT JAM, so NEET PG. So you should definitely select. You should definitely select GATE ESE. GATE ESE. Our classes will be for GATE ESE, and in step 4 you can select something called plus. So as I told you, the advantage of having plus is you will have one-to-one interaction with the faculty members, and many experienced faculty like me are also available on the plus. Many other courses also available. So once you get plus, you can write exams. As I told you, GATE is not just about studying, sir. Studying is just 50%. Listening and studying is just 50%. Practice is the success for GATE exam. So for every subject, you should at least try to practice as many number of as possible as different problems, not just only the previous year questions or some from bits and bytes books. So you should practice as many as possible, right? So you get select plus. Step 4, you should select plus. So what is plus? I told you, and get subscription. Get subscription. Okay. So subscription. So you'll get other subject also. So what is going to be step 6 is you should select the tenure of your subscription. Either you are going for 12-month subscription or 24-month subscription. So if you are interested, you can select 12-month subscription. If you are interested for 2022 or 2023, those who are in second year or third year also, I would suggest you to go for 24 months subscription, and you can use my promo code. This is very important, sir. This is my promo code SVS10. SVS10 is my promo code. You use this promo code and just apply. So you can see proceed payment. You can see something called proceed payment. This is the final step for the payment. The step 7, you can choose any payment method. There are many methods. You can choose a debit card or credit card, whatever. You can pay EMI. You can UPI, something called wallet. You have T wallet, N wallet, UP wallet, anything. Or you can use also net banking. So whatever the fees is there, for that you will get, if it is 12 months, what fee? This is the fees. 24 months, this is the fees. So you'll get Venugopal, good evening. So you will get 10% rebate. I mean 10% discount you will get from this. Okay. So just apply this and you will get it. Is it clear? Yeah. I would suggest to go for anyway, because online is always better right now, as the situations are not good in the present situation. You should just select an online course, right? If you are very serious about GATE and ESE, engineering service exam, or graduate aptitude test for engineers, for engineering. Okay, so whichever you want, you can just go to it. Yeah. So moving on to the next one. So as I told you, today's topic is going to be atomic structure. So in the atomic structure, these are the 3 major topics which we are going to discuss. So what are they, sir? The first thing is going to be Rutherford atomic model. Rutherford is the first scientist who said what would be the atomic model, right? I think in the year of 1911, the scientist Rutherford presented a atomic model, right? But there are some drawbacks for the Rutherford atomic model. Because of these drawbacks, so Bohr proposed another atomic model. Okay. Am I audible to everyone? Asif Basha, good evening. Hope I am audible to everyone. Okay. So before going to start with our atomic model, so what we discussed, the atomic structure. So we need to understand few important definitions. We should. Sandhya, thank you. Audible. Okay. So few important definitions which we need to understand. The first thing is field intensity. So by definition, sir, I am trying to put more text on written text, because as I told you yesterday, my handwriting is not that much what I expected, right? So so I'm just like a student who is starting new handwriting, because this online pad is not much supporting me. So after a few classes, hopefully I'll get a good handwriting. Okay. Okay. So what is field intensity? Force on a unit positive charge in the electric field is defined as the electric field intensity, E. At that point, the unit of electric field intensity is volt per meter. So what is saying? So let us consider, let us say you have some electric field. Some electric field is like this. Let's say you have some electric field, or you may have electric field like this, a circular electric field. Whatever electric field you have. So sometimes electric field is like this. An electric field is, assume this is an electric field. Now what is saying, sir? Now I am going to put one positive charge Q. A positive charge Q is here. Now what happens, sir, when a positive charge Q is placed in an electric field? Some force will be applying on it. So that force per unit charge, the force acting on a unit positive charge is called as field intensity, right? This is an electric field. You are trying to place a positive charge here. So when the positive charge is placed in an electric field, there exists something called electric field intensity on a unit positive charge. So if you write a formula for this, so electric field E is equal to force F per unit positive charge. Force per unit positive charge. Force per unit charge. Sir, what would be the units of this? I've already mentioned. So, but generally, what is unit for force, sir? Newtons. And what is unit for charge? It's going to be coulombs. So this electric field intensity unit will be either newtons per coulomb or you will have volt per meter. Volt per meter. Units are very important, sir. You need to remember these units. Units are very important. E, electric field intensity is equal to F by Q, a force acting on a unit positive charge in an electric field. It's called as field intensity. So this is as imaginary, sir. You should imagine that you are trying to place, you yourself trying to place. Okay. So otherwise you just imagine, sir. Otherwise you just imagine. You are standing on the top of your home. On the top of your home, there will be a forceful wind is coming, air is coming, right? Or a huge air is coming on your terrace and you suddenly went onto the terrace. What happens, sir? You will feel that force. Yes or no? Yes or no? Simple, same thing here, sir. Same thing here. So the electron, the positive charge, when it is placed in some electric field, it feels something called a force, right? So that force is what, sir? So that force per unit charge is called as electric field intensity. Electric field intensity. Clear? Clear? So when you are standing, right, on the terrace, so where a lot of wind is coming, so you will feel that pressure or not. So same thing. So the positive charge, the force on the positive charge is nothing but this electric field intensity. This electric field intensity. Clear? Okay. Now let's move on. Next, what is there, sir? A potential. A potential generally represented with V. Potential V. Right? So that is electric field intensity. This is potential V. The amount of work done in moving a unit positive charge Q from infinity to the required point is called potential. Or electrical potential is a scalar quantity. Either it is scalar or vector, that we will discuss later, sir. Okay. The work done against the field in carrying a unit positive charge from the point Q naught to the point X naught to the point X by definition is called potential. See what I'll do here is wait, I'll do one thing. Take it. Yeah. Let's again imagine you have a point A, here you have a point B. Assume that this is at X naught and this is at X. And so what is saying, sir? What is saying? What is saying, sir? So the work done against the field. What is this against the field? I'll let you know. Don't worry. I'll talk about this. I'll talk about this now. In carrying a unit positive charge from the point X naught to the point X, right? So from X naught to, so you are trying to move a charge. Let's say a charge Q is at, a positive charge Q is at A. You are trying to bring this or trying to carry this from here to here. Or anyway, you can do like this also. Just for the sake of fun, I've done this. So you are trying to move this positive charge. You are trying to move this positive charge from here to here. And the important point you can see here is, he's saying against the field. So when you are moving from here to here means, remember, your field is in this direction. your field, let's say an electric field. Let's say an electric field. Let's say an electric field. So when you're trying to move the work done to move a positive charge Q from A to B, that is from x0 to x, is called potential V. Is called potential V. And it represents that the work done is an integration of from x0 to x, x0 to x, E dx. E dx. But important thing to be remembered is it is minus. It is minus. This is very important, sir. Why minus, sir? Why minus? Why minus? Why minus, sir? Why minus? Because you are trying to do some work. You are trying to do some work against the field. You are trying to do some work against the field. Field is in this direction. Your work is in direction. Field, electric field is in this direction. Your work W is in this direction. So what happens? What happens if, let's say, this point A is here, point B is here, electric field is also in this direction, and you are also trying to move this. You are also trying to move. You are also trying to move from here to here. You are trying to move this positive charge from here to here. What happens, sir? No. Do you think it is going to be integration of E dx? No, you don't need any work to be done because you have some electric field, and as we just now we discussed, this positive charge feels some force. So when the always electric field is from higher potential to lower potential. Higher to lower. So obviously this will move. You need not worry. You need not worry. So this correct. So this minus sign indicates, you are trying to do some work against to the field. You are trying to do some work against to the field. Okay. Okay. Now we will move. Here comes something called potential energy. So what we discussed here, we discussed electric field intensity. Then we discussed potential. So whether we have relationship between electric field intensity, potential or not? Yes or no? Yes. We have some relationship between electric field intensity and potential. Now here comes the third one. Something called potential energy. Potential energy. So what do you mean by potential energy? The potential energy is equal to the potential multiplied by the charge under consideration. Charge under consideration. Potential energy. So simple, sir. This is very simple. Potential energy is equal to what is saying, sir? Equal to the potential. This potential. What is that potential, sir? Just now we have written this potential multiplied by charge Q. Charge Q. So potential energy. What is potential energy? What is potential energy, sir? Potential energy is very simple. Potential multiplied by its charge, or a charge multiplied by its potential. Both of them are same. Okay, both of them are same. So potential energy is nothing but charge multiplied by potential. So potential energy. So electric field intensity followed by Potential followed by potential energy. These are the definitions. We have one more definition here. So this potential energy, what are the units for energy, sir? We represented with the joules. Joules, right? Unit of energy is going to be joules. Unit of energy is going to be joules. But here comes something called the EV unit, electron volt energy, unit of energy. So why do we need this? Why do we need this? Why do we need this? And it is showing 1 electron volt is equal to 1.60 10 to the power minus 19 joules. Sir, very simple, sir. Very simple, sir. Now we will discuss something which is quite normal. Quite normal. Sir, how will you measure? How will you measure the weight of a human being, sir? How will you measure the weight of a human being? So somebody says, sir, in kgs, right? In kgs, or somebody says, sir, pounds, or somebody says something, right? Sir, kgs, right? Kgs is, let's say, you are using to measure the weight of a human being or something. So how will you measure some glossaries? So which is less than kg. So you will have something called grams. Sir, it is less than grams. Let's say you are trying to buy gold or something which is very less. You will have something called milligrams. All these are units for weight only. All these are units for weight only. All these are units for weight only. Okay. All these are units for weight only. Similarly, for energy, we have different units, right? So generally, the units for energy, the energy units are joules. Let's say we are trying to measure something which is less than joule. So there is something called erg. What is erg, sir? Erg is equal to 10 to the power of minus 7 joules. 1 erg. Erg is also unit for energy only. Erg is also unit for energy only. So 1 erg is equal to 10 to the power of minus 7 joules. 10 to the power of minus 7 joules. So the quantity for which generally the energy of a semiconductor devices which we are talking about, or an electron, which is very, very less even when compared with erg. That is the reason why we need another unit which is very, very smaller than erg or joule. That is electron volt. Sir, why this electron volt? Why we don't have some other name? Because in the previous slide we have seen, if you go here and see, that is the potential energy. Potential energy is what, sir? Q into V. So here, potential energy, I think what? Q into V. So this is electron. Let's assume electron. This is volt. So as potential energy, if we are trying to measure, so we can use some name called electron volt, which is also the unit of energy, which is also unit of energy. Frankly speaking, let's assume a charge q is falling. A charge q is trying to fall by an amount of, let's say, trying to fall from here to here. From here to here, which is having 1 volt, which is losing 1 volt potential. So what happens here? QV, right? Q into V. So what is Q? 1.602 into 10 to the power of minus 19. The coulombs is the charge of a positive charge, multiplied by 1 volt. Multiplied by 1 volt. So what you will get, sir? Simply you will get energy or not? Yes or no? Yes or no? You will get energy only. So this is nothing but 1 electron volt is equal to 1.602 into 10 to the power of minus 19 electron volts. Joules, sorry. Joules. So that is what he mentioned, right? Sir? So 1 electron volt is equal to 1.602. Here what you will write? 10 to the power of minus 19 joules. 10 to the power of minus 19 joules. Clear? Is it clear? So how do we get this, sir? So don't think that a electron volt is something different. Electron volt is also a measure of energy, just like joules and ergs. As we measure the weight of different groceries or different matters, so you have something called kilograms, grams, milligrams, pounds, and as different will. You'll also measure some distances, right? Distances, somebody measures with the feet, somebody measures with centimeters, somebody measures with meters. Similarly, so we have another unit for energy, that is called electron volt. Don't think something. But what is 1 electron volt is important. What 1 electron volt is equal to 1.602 into 10 to the power of minus 19 joules. 1.602 into 10 to the power of minus 19 joules. This is very important. Now, so before moving to the Rutherford atomic model, something another thing which I have to mention is, so I'm trying to write it on a rule notebook, right? As like a small student, I'm trying to do this. Okay. Yeah. Bear with me. Bear with my handwriting. If I'm right on my normal board, I'll write very well. But here it is not supporting. So I'm trying to do it. Okay. So what is matter? Which is important is, what is matter? Anything which has certain weight, and occupy some space is called matter. Matter is nothing but which has some weight and occupies some space. So every matter is subdivided into molecules. every matter is subdivided into molecules. So, but this molecule has all identities, all identities. So, same identity, sir, same identity. It will not change its identity. It will not change its identity. So, matter is divided into molecules with the same identity, and each molecule is again subdivided into smallest minute particle called atom. Smallest minute particle called atom. Okay. So matter, what is matter, sir? Matter is nothing but which has some weight and which occupies some space. Matter is something which has some weight and occupies some space, is called matter. Matter is again divided into something called molecules. Each molecule again subdivided into atom. Each molecule is subdivided into atom. Okay. And atom composed of three important elements. Something called electron, proton, of course you know all these things, and neutron. Electron, proton, neutron. So understand very importantly, sir. Anything which has some weight and occupies some space is called matter. Matter is divided into molecules. Molecules again divided into atoms, subdivided into atoms. And each atom consists of these fundamental particles. So electron, proton and neutron. Electron, proton and neutron, which is very important. Now we'll move on. So here comes something called Rutherford Atomic Model. So what Rutherford is trying to say is, the center of an atom consists of a positively charged body, which is called nucleus. All the protons and neutrons are present in the nucleus. Okay. And the electrons keep revolving in the orbits around the nucleus at extremely high speed and at a large distance from nucleus as the planets revolve around. Okay, so let me explain with something. Okay, let's get some space. Shapes, I need some space. I'm trying to draw something different, sir. So I'm trying to draw what Rutherford is told. Okay. So center of an atom consists of positively charged body, which is called nucleus. So this is the nucleus. Assume that this is going to be nucleus. This is nucleus. This is nucleus. Right? What is saying, sir? It has some positive charge. It has some positive charge. Nucleus has some positive charge. Who is saying, sir? Rutherford is saying. Right? And electrons revolve around the nucleus at extremely high speed. So what they are trying to do, sir? They are trying to revolve here. Understand? Let's say here you have some electron. So they'll try to revolve around the nucleus. So this is the nucleus, and these are the electrons. These are the electrons. These are the electrons. electrons. What they will do, sir? They are revolving around the nucleus with high speed. With high speed at a large distance from the nucleus. Okay, how is, see how the planets revolve around the sun. So I'll try to show you some video. You just see this video, you'll try to understand. You see what's happening here, sir. So assume that this is going to be, I'll show you again. So this is this red and white balls are going to be the nucleus part, center part, protons and neutrons, and this blue balls are there, right? So they are like electrons which are trying to revolve around the nucleus, Clear? So an atom consists of this. So you can see here what's happening. So this red and white considered as protons and neutrons, and this yellow are called electrons. This yellow can be imagined as electrons. Is it clear? Okay. So coming back. So this is what he proposed. What he proposed, sir? Nucleus is having some positive charge which consists of protons and neutrons, right? And electrons are revolving around the nucleus as planets revolve around the sun, right? As in solar system, what happens, sir? All our planets, all the 9 or 8 planets are revolving around the sun. Now, just now I showed a video, same like that. Is it clear? I think it is clear for all of you. So this is what Rutherford model is saying. So, and we call these as orbits. These are called orbits. These are called orbits. They're called orbits. This is called nucleus, which contains protons and neutrons. This is what he said. So the electron is trying to have an extremely high speed, large distance, at large distance. So it is away from the nucleus and trying to revolve around the sun. This is simply he's saying. Now here comes, right? So this is simply we will try to derive. What is exactly he's trying to say. So, but some important things to be considered here is atom is electrically neutral because the charge of proton is positive and electron is negative. Obviously, if we go and see, you can see here this is positive charge, this is negative charge. These are negative. And how many number of electrons are there? Those many number of protons will be here. Okay. So because of that, what happens, sir? It is always electrically neutral because the charge of proton is positive and the electron is negative. So this is very much important to be remembered. So to confuse you in the examination, he may give you. This is very simple. And what I'm talking is about. So very simple. So electron is always neutral. Electron is electrically neutral because it has positive charge and electron has been having negative charge and proton is having positive charge. Electron is having negative charge and proton is having positive charge. So what would be the mass of an atom? Mass of an atom is going to be 1.9 into 10 to the power of minus 26 kgs. So one thing here you have to remember is, very important thing which I am telling you here is, most of the mass of the atom will be concentrated only at the nucleus. The mass of electron is very less. The mass of electron is very less when compared with the mass of protons and neutrons. Protons and neutrons. So the atom means the mass. The mass of an atom means only most of the time we will consider the mass of protons and neutrons, not electrons. Electron mass is very less and which is also trying to move around. Which is also trying to move around and it is very difficult to calculate the mass. So another important thing is here atomic number. Atomic number. What is atomic number? Atomic number Z is nothing but number of protons or electrons in an atom. Right? Z represents number of protons or electrons. Why sir? Or why I am saying R sir? Because in an atom, how many number of protons are there? Those many number of electrons are also there. Those many number of electrons are also there. So you may ask me, sir, you can write P or you can write E. So to avoid this confusion, we choose some other number called Z, some other letter Z. Z is an atomic number. Now what is atomic mass number? Atomic mass number is the summation of atomic number plus number of neutrons. This represents neutrons. Clear? Atomic mass number is a summation of. Sir, you may think that I am going very slow. But these are very fundamentals. This is very fundamental. That is the reason why I am telling each and everything, repeating it again and again. If you are comfortable with this, if you remember this, all this very well, then only you will have good knowledge of semiconductor devices. That is why I am stressing again and again this. Many people might be already knowing about all these things, but I'm still trying to stress all of this because there might be some students who are from second year also. So for them it will be very, very useful. For them it will be very, very useful. That is the reason why I'm stressing it again and again. Okay. So coming back, atomic number is nothing but number of protons or electrons in an atom. Atomic mass number is nothing but, which is represented with A, sir. Which is represented with A. A is nothing but summation of atomic number and number of neutrons. Number of neutrons. Clear? Now, moving on to the. Achha, this is also existing. So we have charge of electron 1.62 10 to the power minus 19 coulomb. This you need to remember this. Mass of electron is 9.0 10 to the power minus 31 kgs. Sir, see how much is the difference. So if you go and see in the previous slide, it is going to be 10 to the power of minus 26. Mass of an atom is 10 to the power of minus 6. Now what is the mass of electron? 10 to the power of minus 31, not positive plus 31, sir. It is minus 31. Okay. Minus 31. This is minus 31. Means very, very less. Very, very less. Almost 1 lakh times. So mass of an atom is 1 lakh times the mass of an electron, which is very, very high. So because of that, generally we neglect the mass of an electron. Now you see, radius of an electron is 10 to the power of minus 15. Radius of an electron is 10 to the power of minus 15. Whereas the radius of an atom is very high. 10 to the power of minus 10. Again, this is also almost different, sir. 10 to the power of 5. 10 to the power of 5. So what happens, sir? So radius of an atom is also very, very important, which is very high. Which is very high. Whereas the radius of an electron is 10 to the power of minus 15 meters. So mass of an electron is always negligible. Mass of an always, I'll write here. Mass of an electron is negligible. Negligible. Sorry. Negligible. When compared with mass of an atom. Mass of an atom, because almost there is 10 to the power of 5 times. 10 to the power of 5 times. Right? Now we'll move on. Before going to discuss about this, so I have to do something very important here. Remember, sir, this now next discussion is very important, right? So what is there, sir? I will try to wait. I'll try to take that again. I'll try to take that again. These shapes I have to take again. Just give me one second. Yeah. So here exists a positive charge. Let's consider for hydrogen. Let's consider for hydrogen. Let's assume that we are talking about hydrogen. Hydrogen, which has one electron and one proton, which is having some, let's say, positive charge, right? Some positive charge. So this is an electron which has a proton which has a positive charge Q, and this is an electron which is having minus Q. This is having this Q. So according to Coulomb's law, what happens, sir? According to Coulomb's law, there exists a force of attraction between these two. There exists a force of attraction between these two. So what is Coulomb's law, sir? F is equal to Q square by 4 pi epsilon naught into R square. So we have one positive charge, one negative charge. You can also call plus Q minus Q, or you can say minus C or plus C. So I assume that this is going to be F is equal to E, positive charge, and then minus E by 4 pi epsilon naught into R square. So the force of attraction between these two is going to be minus E square by 4 pi epsilon naught into R square, where E is the charge of electron, R is the radius, of an atom. So here R is radius of an atom. Then what is epsilon naught, sir? Epsilon naught is permittivity of the free space, which is equal to permittivity. Please bear with my handwriting. Okay. Okay. Permittivity of free space. Can somebody remember what is the value? How should I write? So it is going to be 8.854 into 10 to the power of minus 12 farads per meter. Farads per meter is the permittivity of the free space. So the force of attraction between these two electrons is going to be 4 pi minus E square by 4 pi epsilon naught into R square. Right. Now here another important thing to be remembered here, sir. So what is saying, sir? This charge Q is trying to revolve around the nucleus with high speed. let's say it is moving. So this force of attraction is nothing but it. So here you will have a force of attraction. Here you will have a force of attraction. Assume that this is going to be force of attraction F. And the electron is moving with the velocity in this way. Let's say with velocity, with some velocity v, some velocity v, with some velocity v, and there exists another force exactly opposite to this. Exactly opposite to this. What is that? Called centripetal force. This is centripetal force. This is centripetal force. According to so this force, which is the force of attraction, is equal to, which is also having something called, which will be compensated by some another force called centripetal force. So what is the formula for centripetal force? Centripetal force is equal to simply mv square by r. mv square by r. mv square by r, where m is the mass of an electron, v is the velocity with which it is traveling, rotating, revolving, and r is the radius. R is the radius of an atom. R is the radius of an atom. So these two will be equal, sir, because if the electron is revolving means, if your electron is revolving means, these two forces will be equal. Force of attraction is equal to centripetal force. Centripetal force. So what is force of attraction which we have discussed, sir? This is going to be minus E square by 4 pi epsilon naught into R square, which is also equal to mv square by R. I am also trying to mention again here something called minus. I am putting minus here. Why minus, sir? If you look at the previous case, the force of attraction and the centripetal force are in opposite direction. That is the reason why I am trying to put the minus here. I'll put this is in red, better to. So now what happens, sir? This minus will get cancelled. So what will be remaining, sir? So R will get cancelled. So you will have something called mv square is equal to, sir, why E square R get cancelled, sir? Here what I am trying to do is here R and R square will get cancelled. So E square by 4 pi epsilon naught into R. 4 pi epsilon naught into R. Sir, this is important, sir. In coming days we will use this formula also. In coming discussion we'll use this formula also. Right? So one is what we discussed, sir. So this in the previous slide, this force of attraction, and here this is centripetal force. The F is equal to minus E square by 4 pi epsilon naught R square, and this is going to be centripetal force. Centripetal is mv square by R, and this mv square is equal to minus E square by 4 pi epsilon naught into R. Right? Now the energy of electron is a summation of potential energy and kinetic energy. So, I'm going very slow. Again, I'm telling you, this is for the entire students who are listening, sir. Right? So, energy of the electron, let's say W, is a summation of its potential energy plus kinetic energy. Potential energy and then kinetic energy. So, what is potential energy? What is the potential energy? Q into V, which we have discussed. Q into V, that is also equal to minus of E square by 4 pi epsilon naught into R. And what is the kinetic energy? We know that kinetic energy would be half mv square. Half mv square. We can see here, this is going to be minus E square by 4 pi epsilon naught into R plus half into, what is mv square? Just now we discussed, this is going to be what, sir? E square by 4 pi epsilon naught into R. So, this is going to be 1 by 8, this is going to be minus 1 by 4. So, in the next place, we'll write this is equal to minus E square by 4 pi epsilon naught into R plus E square by 8 pi epsilon naught into R. So, what will be remaining, sir? You will get the energy of an electron is going to be minus E square by 8 pi epsilon naught R. 8 pi epsilon naught R. This formula is also very important formula. I am struggling to write it. I can understand. It is something. So just bear with me for a couple of days or so slowly. I think my handwriting will improve. So once my handwriting will improve, so you'll feel better. I think, but still you are understanding, right? कोई दिक्कत है क्या? I think you don't have any issue. FC, good. Okay. So W is equal to the work done or the energy of an electron. The energy of electron is nothing but minus E square by 8 pi epsilon naught n. So you can see something again here negative. You have again negative. Here you have negative, sir, negative. So electron charge is negative. Energy of an electron is negative. So what does it mean, sir? As electron approaches the nucleus, energy of the electron decreases. Okay. So what is saying, sir? If the electron is trying to come, to close to the nucleus, it loses its energy. That's what, right? So what it is saying? From this, energy of electron is negative. Energy of the electron is negative. So what does it mean, sir? As it's trying to come closer, and as electron moves away from the nucleus, the energy of the electron increases. Okay. So energy of the electron is negative. So this is what we have to discuss. So what formulas we should remember, sir? 3 formulas. This is what? The force of attraction between 2 electrons minus E square by 4 by epsilon r square. This is from Coulomb's law. And next, this is what mv square is equal to E square by minus 4 by epsilon naught r. The most important thing is here, the energy of the electron. The energy of the electron is going to be, sir, some problems will also be asked based on this. Some problems will also be asked based on this formula, sir. That's called W is equal to minus C square by 4 pi epsilon naught. This is also negative. So as electron comes closer to the nucleus, its energy decreases. When it is moving away from, the nucleus, its energy will increase. Its energy will increase. Very simple, sir. Very simple. So generally, what happens in your colleges also, if you are trying to go very close to the faculty members, you will become very alert. You will become very alert and become silent. If you are moving away from the faculty, you start shouting. Yes or no? In general, you do it in the college or not, right? Similarly, you imagine that you are an electron. When you are moving away from the faculty, your voice will increase. Yes or no? But when you are coming closer to the voice, you will say, "Sir, sir is coming. Sir is coming. Sir is coming. Let's talk slowly. Let's decrease the voice." Okay. So same thing. Energy of electron is negative. When the electron is trying to come closer to the nucleus, its energy decreases. Its energy decreases because the force is high, sir. Nucleus is trying to pull it, right? So when it is trying to come away from away and coming away from the nucleus, and it is coming closer to the nucleus, its energy decreases and its speed also decreases. Right? So when it is away, so it will revolve. It will revolve around the nucleus. This is what we have derived from Rutherford atomic model. So what is the drawback of Rutherford atomic model? Or what is the weakness of atomic? According to the classical electromagnetic theory, if a charged particle accelerates around an oppositely charged particle, the former will radiate energy, its speed will decrease, and it will go into spiral motion, finally falling into the nucleus. So what is trying to say is, when two charges, let's say this is a positive charge and this is let's say some nucleus is here, and this is going to be a negative charge. So when it is trying to move around, when it is trying to move around the nucleus, sorry. So just let me take something here so that you will. I don't need this also. I'll try to draw only, right? Don't worry. I'll try to draw this. I'll try to make you to understand very well. Let's say you have a positive charge Q. Around this, a negative charge is moving. Assume that this is going to be circle or ellipse, whatever. Assume that I'm saying just assume. Okay, this is going to be the electron moving. It is worst. So electron is moving around the nucleus. Which is negative in charge. So what happens, sir? When oppositely charged particle, it is revolving around, accelerates around an oppositely charged particle, the former will radiate energy. So what happens, sir? This electron will start radiating energy. When electron radiates energy, it loses its energy. Yes or no? When it loses the energy, slowly it comes down. When it loses energy, what happens, sir? Earlier, what we had discussed, sir, when electron is coming towards the nucleus, its energy loses. So when energy loses, when electron loses an energy, it comes closer to the nucleus. nucleus. So, but slowly what happens is it will form a chiral space. Let's say what happens is here I will try to draw Q. So here is an electron. Which is supposed to move in a circle. Slowly by losing energy, it will become a spiral. It will become a spiral, but at one point of time, it will fall. At one point of time, it will fall into the nucleus. According to him, according to Rutherford, what he says is, it is moving in the opposite direction. But from electromagnetic theory, from classical electromagnetic theory, what happens, sir? This when two charges are moving in opposite, when one charge is moving around the nucleus, around the other opposite charge, what happens, sir? It radiates energy or it loses energy. And it loses energy, it will fall. Is it happening, sir? It doesn't happen because the atom is stable. If this is true, if the electron is falling into the nucleus, what happens, sir? If the electron is falling into the nucleus, what happens? There is no atom at all. There is no electron at all. There is no electricity at all. This world is not existing. So because of that, this is wrong. So now here comes another scientist called Bohr. What Bohr says is, according to Bohr's atomic model, atom can possess only certain discrete energies. So understand this. This word discrete is very important. What is saying, sir? Discrete energy. While in states corresponding to these discrete energies, the electron doesn't emit radiation, and the electron is said to be in stationary or non-radiating. So whatever is saying is very important. One minute. Okay. Now assume that this is going to be the nucleus. This is going to be nucleus, and electrons are revolving around the nucleus. So he says something called atom can possess certain discrete energies while in states corresponding to these energies. So atom has discrete energies. Not continuous energies. What do you mean by discrete? Discrete is nothing but opposite to the continuous. Continuous means you have some values, let's say 1, 1.1, 1.2. So all these comes under continuous. But discrete values, what is this? Discrete is nothing but like this. You will have, wait a minute. Discrete energies, not continuous energies. Some value. Let's say this has some 1 volt. So some 1. So this is nothing but, let's say, discrete. Step is discrete, sir. You have 1, 2, 3, 4. Either you can be at 1, either you can be at 2, either it can be at 3, either it can be at 4. You can't be at 1.5. Can you stand at 1.5? No, you can't stand. You have some definite energy, definite values. 1, 2, 3, 4. This is nothing but discrete. So similarly, this atom has some discrete energies. Atom has some discrete energies. When the electron is present at this discrete energy levels, the electron will not radiate. Electron will not radiate or emit radiation. So in the previous problem, what was the problem, sir? In the previous proposal, so electron is, when it is radiating energy, it is falling into the nucleus. It is falling into the nucleus. But here, what is saying, sir? When the electron is in having this discrete energy levels and revolving around, what happens, sir? The electron will not fall. The electron will not fall and will not emit radiation at all. And this is called stationary. Electron is called stationary. Stationary, or it is non-radiating state. It is called non-radiating state. Electron does not emit radiation and electron is said to be at stationary. Electron is said to be at stationary. And this is non-radiating. What is it? Clear? And now, from moving. In this transition from one stationary state to the corresponding to the let's say energy. Okay. So again, what is saying, sir? I have to take this again, or I'll try to I'll try to take this. Let's say an electron is here with having a energy W2, and here another electron is there, or this energy level W1. So according to him, energy will be radiated only when it is moving from W2 to W1. So first thing which you need to remember is, when electron is revolving around a nucleus in a stationary orbit, we call stationary orbit, it will not radiate energy. But energy will be radiated when it is moving from one energy level to the another energy level. Energy will be emitted when you are moving from one energy level to the another energy level. So this is what is it. And the frequency of radiating energy is given by that frequency of radiating energy, F is directly proportional to the difference of energy levels. F is directly proportional to W2 minus W1. So, and you have a constant of proportionality, F is equal to H into W2 minus W1. H is equal to W2 minus W1. This is also one important thing. So according to Bohr, what is saying is correct. So this is W2 minus W1. This is W2 minus W1. Yes, I know I am teaching very slowly. But for the benefit of everybody, I am teaching very slowly, sir. For the benefit of everybody, I am teaching very slowly. Okay, I am teaching very slowly. So now this is very important to be remembered. constant of proportionality. Oh, sorry. Constant of proportionality is going to be W2 minus W1 by H. I'm sorry, I forgot it. I'm sorry. So F is equal to 1 by H into W2 minus W1. W2 minus W1 by H. What does it mean, sir? Very simple, you see here. Assume this is n is equal to 1, n is equal to 2. I'll tell you what is n also. N is equal to 3, n is equal to 4. So when electron is moving from one energy level to the next energy level, that is, it is coming down closer to the nucleus, then only, so this is having an energy of W2, this is having the energy of W1. The frequency of radiating energy is equal to the difference of energies between these two levels. That is, F is equal to W2 minus W1, where H is, what is a Planck's constant? H is Planck's constant. Can somebody tell me what is Planck's constant value? Can anybody remember? What is Planck's constant? Planck's constant is nothing but 6.626 into 10 to the power of minus 34 joules second. Planck's constant value. The value of Planck's constant is going to be 6.626 into 10 to the power of minus 34 joule second. And what is the radiating energy? This is radiating frequency F. Then what is the radiating energy? Simple, sir. Simple. Cross multiply it. So you will get W2 minus W1. W2 minus W1 is equal to, that is the difference of energy is nothing but F into H. Yes or no? F into H. F into H is nothing but the energy. Energies. So W can I write W as a Q into E? Yes or no? So HF is equal to Q into E. So this can also be written as 1.602 into 10 to the power of minus 19 coulombs into E2 minus E1. E2 minus E1. This is also another important formula you should remember. Problems may come, problems may ask in the examination. In the examination, you will get some problems on this. HF is HF is equal to 1.602 into 10 to the power of minus 19 coulombs. So, but what we know, sir, can I say F is So we know that F is equal to C by lambda. F is equal to C by lambda. C by lambda. Substitute here, sir. What happens, sir? H into C by lambda is equal to 1.602 into 10 to the power of minus 19 coulombs into the energy differences E2 minus E1. E2 minus E1. E2 minus E1. Sir, we know the value of H, we know the value of C, and this is a constant. We don't know these two. So if you substitute H and C, what you are going to get is the value of lambda you are going to get. So lambda is equal to H into C into H into C by 1.602 into 10 to the power of minus 19 into E2 minus E1. Substitute the value of H and C. What you will get is lambda is equal to 1.24 micrometers by E2 minus E1. This is in lambda. This is very important, sir. This is very important. Formula. We'll try to do one problem also based on this. This is in micrometers. Sir, sometimes what happens is they will also mention the formula of this lambda, the wavelength. Lambda wavelength is equal to 12400 by E2 minus E1. E2 minus E1. E2 minus E1. This is also very important formula, sir. This formula you should remember. This formula. This formula you have to remember. Lambda is equal to. So, but it is in terms of angstroms. This is in terms of angstroms. So, what is an angstrom? So, 1 angstrom is equal to 10 to the power of minus 4 micrometers. So, in the examination, you may ask you in terms of angstroms or micrometers. You should just definitely see. So, we'll see one problem which has come in 2014, set number 4. The cutoff wavelength in micrometers of light that can be used for the intrinsic excitation of semiconductor material of band gap Eg is equal to 1.1 electron volts. Can you please try to do, sir? I will wait for some time. I will give you 30 seconds or 1 minute. If you have pen and paper, please, can you do it, sir? Can you try? If you have pen and paper, can you try? If you have pen and paper, can you try? What will be the answer? Simply is asking wavelength. Energy gap he has given. He has given energy gap already. Think. Can somebody try, sir? Can somebody try? Can somebody try? What is the given data, sir? I will try to solve. So what is the given data? Energy gap he has given. Energy gap is 1.1 electron volts. So this is nothing but he has given already E2 minus E1. E2 minus E1 he has already given. What is that? 1.1 electron volts. So what is asking, sir? Is simply is asking for lambda how much? So simply substitute the formula. Lambda is equal to is asking in micrometers. So in micrometers means this is going to be 1.24 by 1.1. Simply you will get the answer is I think 1.1 by 1.11 1.1 something like 1.125. So answer is B. Answer is B. Simple, very simple. See, even in 2014 you got simple, sir. Don't think that you will get a very difficult problems. Yes, you will get difficult problems, but most of the problems are not difficult if you just apply formulas. In EDC, you should remember formulas. In EDC, you should remember the formulas. So C Charan, very good, C Charan. B, Hep C, good. Hep C Princess and C Charan, good. Right answer. B is the right answer. B is the right answer. Congratulations, very good. That shows that you are at least listening to my class. Because EDC is, you feel just sometimes you have to concentrate more to understand EDC, sir. It's not so easy like any other subject. So EDC is theory is very much important. In EDC, theory is very much important. EDC theory is very much important. Okay, let's move on. The third point in the Bose atomic model. So, in third point in the Bose atomic model is a stationary state is determined by the condition that the angular momentum of the electron in this state is quantized and must be an integral multiple of h by 2 pi. What is the angular momentum? What is saying, sir? Understand. We have discussed, right? This is what is stationary. This is stationary orbits. These are stationaries. This is called stationary. This is one stationary orbit. This is one other stationary orbit. Okay. So stationary state is determined. A stationary state is determined by the condition that the angular momentum of the electron in this state. So what is angular momentum formula? Simply angular momentum is going to be mvr. This is an integral multiple of what is saying h by 2 pi. mvr, the angular momentum, is equal to the integral multiple of h by 2 pi. So from this, what can I write is, we can write v is equal to n h by 2 pi m into r. 2 pi m into r. But what we know, sir? What we know? We know earlier mv square is equal to e square by 4 pi epsilon naught into r. Sir, this epsilon naught into r. We have derived in the previous discussion, sir. If you go and see here, mv square is equal to E square by 4 pi epsilon naught. In this class also only we have discussed. In this class only we have discussed. Okay. So mv square is equal to E square by 4 pi epsilon naught into r. mv square is equal to 4 pi epsilon naught into r. Now you substitute this. Let's assume this is going to be 1. Substitute this v value here. If you substitute this v value here, what you will get, sir? M is m into what is v, sir? V is nothing but n into h by 2 pi m into r whole square. mv square is equal to E square by 4 pi epsilon naught into r. 4 pi epsilon naught into r. So if you do everything, what will be your, what will get, sir? So you will get m into n square h square by 4 pi square m square r square is equal to E square by 4 pi epsilon naught into r. So this r and this r will get cancelled, m and m will get cancelled. What we need is we need the value of r. R is equal to epsilon naught into this. Here it is going there, sir. This is also 4 and pi will also get cancelled. So epsilon naught into n square h square by n square h square by pi m into e square. So, but what is the energy of electron? Energy of an electron W is equal to, we have derived, sir, minus E square by 8 pi epsilon naught into r. Now if you substitute this here, the value of r, so what it is going to be, sir? E square by 8 pi epsilon naught into E naught into n square h square by pi m is pi m e square. So what you will get here is W is equal to minus m into e power 4 by 8 epsilon naught square into h square into 1 by n square. So why I have separated this 1 by n square is, if you see, for an electron all these are constant. M is constant, E is constant, M is mass of an electron, E is a charge of electron, epsilon naught value we have already substituted, we have been already, H is Planck's constant, all these constants, and this is also very important formula, sir. This is also very important formula. Sir, don't worry, we will summarize all the formulas. Once again. You need not worry. We'll summarize all the formulas once again. You need not worry. Okay. So W is equal to minus m e power 4 by 8 epsilon naught square h square into 1 by n square. So if you substitute all the values, all the constants, what you will get is, let's say for hydrogen, for a hydrogen atom, for a hydrogen, you know everything. So W value is going to be minus 13.6 by n square, and units are electron volts. This is a very important formula. After substituting, what you will get is this. Clear? So the energy of an electron is electron is inversely proportional to 1 by n square. What is that n, sir? What is that n, sir? It's a state or the orbit in which it is revolving, where n represents orbit. N is orbit number. N is orbit number. N is orbit number. Clear? N is orbit number. So, sir, this formula you have to remember. We may get some problems on this. We may get some problems on it. Again here, the energy is negative. Why, sir? Again slowly. What happens? When the electron is coming towards the nucleus, its energy will be decreased. Yes or no? Are you able to understand? So the negative sign indicates the energy will be decreased. So any doubts if you have, please let me know. So, sir, very important thing to be remembered, sir. Very important thing to be remembered here. So as n increases, as the n increases, what happens? Energy of electron, energy of an electron increases. Though the energy of an electron is inversely proportional to the orbit number, but here you have a negative sign. Energy of electron is inversely proportional to the number of orbit number, but this negative sign, because of this negative sign, what happens here? If the orbit number is increasing, energy of the electron increasing, means when you are moving, if you go and see this one. So for n is equal to 1, you have the lowest energy level. So as n is increasing, energy is increasing. So what does it mean? You are trying to move away from the nucleus. When let's say this is n is equal to 1, this is n is equal to 2. You may have another circle here, which is n is equal to 3. So as the n value is increasing, the energy of electron is also increasing. Of course, by formula, energy of an electron is inversely proportional to the orbit number. Clear? It is inversely proportional to the orbit number, but it is because of the negative sign, its value. So as the n value, as the orbit number increases, energy of the electron also increases. Energy of the electron also increases. So we will discuss the remaining in the next class. I think if you have any doubts, you can ask me. If you can post me some queries right now. So because it's already 2 hours of the class, so if you have any questions, so I'll just take some questions, or we'll quickly go through what we have discussed. We'll go to some summary. We'll go to some summary and close the session. Go to some summary and close session. I'll just wait for 1 or 2 seconds or one minute. Sir, first theory, sir, this semiconductor theory part will be of more of theory, sir. More of theory. You need to concentrate more. I'll be going very slowly, as I told you. I'll be going very slowly. So it will be difficult. So let me quickly summarize what we have discussed. So we started with something called field intensity. What is field intensity? Is a force on a unit positive charge. Force on a unit positive charge is called field intensity, and the units of that is going to be volts per meter. Then we will discuss about potential, the amount of work done in moving a unit positive charge, or the work done against the field in carrying a unit positive charge from point x0 to x is called potential V. Okay, potential V. And we have discussed how it has come. The negative sign indicates that you are trying to do the work opposite. Okay, then what is potential energy? Potential energy is nothing but simply the multiplication of, equal to the potential multiplied by the charge under consideration. So Q into V, the units are going to be joules. Potential energy units are going to be joules. And electron volts is also another unit of energy, because joules is very big unit when compared with the energy of an electron. Of course, if many number of electrons come together, it may become joules. But electron volts is a unit for the smallest unit of the energy. Simply like how grams, kilograms, milligrams, micrograms will be there, right? So similarly, electron volt is a unit of energy. Electron volt is the unit of energy. This we have seen. 1 electron volt is going to be 1.602 10 to the power minus 19 joules. 1.602 10 to the power minus 19 joules. So then we have discussed what is matter. Matter is nothing but anything which has some weight, and space is nothing but matter. And matter can be classified into molecules, subdivided into molecules. Molecules are again atoms. Atom has 3 fundamental things, which are electron, proton and neutron. Electron, proton and neutron. And then we have seen Rutherford atomic model. In the Rutherford atomic model is nothing but the center consists of, called nucleus. Nucleus consists of what, sir? Nucleus consists of what? Protons and neutrons. Protons and neutrons. And electrons will be revolving around the nucleus with high speed, right? Just like as the planets revolve around the sun. So we have seen what is the mass of an atom, atomic number, mass number. Atomic number and mass number are different. Atomic number is nothing but the number of protons or electrons. Atomic mass number is going to be Z plus N, that is protons plus neutrons. Okay. Then we have seen the charge of an electron and everything. We have seen the mass of electron is negligible when compared with the mass of an atom. That's also second. And then, so now we have discussed something that when there exists a positive charge and negative charge, there exists a force of attraction, and that is according to Coulomb's law. We have seen F is equal to minus q square by 4 pi epsilon naught r square, and definitely there will be an opposite force which is called centripetal force, whose formula is going to be mv square by r, and these two are going to be equal. So then mv square is going to be e square by 4 pi epsilon naught r. energy of an electron is going to be minus e square by 4 pi epsilon naught or plus half mv square. So minus e square by 4 pi epsilon naught or plus the derivation we have done. The derivation we have done, and we got energy of an electron is negative. That is going to be W is equal to minus e square by 4 pi epsilon naught into r, minus e square by 4 pi epsilon naught into r square is the energy of an electron, which is negative. So what do you mean by it is, when the electron is moving away from the nucleus, its energy increases. When electron is coming towards the nucleus, means its energy will be decreased. Then we have seen what is the weakness of Rutherford. According to Rutherford, when the electron is revolving around the nucleus, it loses some energy. When it loses energy, it has to take a circular path, not circular path. It takes a spiral path, and because of the spiral path, it is supposed to fall. It is supposed to fall into the nucleus. It is supposed to fall into the nucleus. Is it falling into the nucleus? Is it falling into the nucleus? No. Actually, it is not happening. Actually, it is not happening. So this is the problem of Rutherford atomic model. So then what Bohr is saying? According to Bohr, atom can possess only certain discrete energies, while in states corresponding to these discrete energies, the electron doesn't emit radiation. So when the electron is the summary we are discussing, when the electron is in some state called stationary state, it doesn't radiate energy or non-radiating energy. So it radiates energy only when, in the second point, what is saying, sir, it radiates energy only when it is moving from one stationary state to another stationary state. One stationary state to another stationary state. And that frequency of radiating energy is always proportional to the difference of the energies, W2 minus W1. W2 minus W1. So F is equal to W2 minus W1 by H. H is a Planck's constant, whose value is going to be 6.626 into 10 to the power of minus 34 joule second. So here you can see when the electron is moving from one state to other state, W2 to W1, it releases some energy, and that is. So we have seen what is the formula for this lambda. So lambda is the wavelength of an electron is going to be 1.24 micrometers. Sir, you should remember this. Micrometers is very important. In the question, he may ask you in micrometers or in angstroms. So 1 angstrom is once again 10 to the power minus 4 micrometers. 1 angstrom is equal to 10 to the power minus 4 micrometers. Angstrom is going to be 10 to the power of minus 4 meters. And we have discussed one problem. What is that, sir? Cutoff wavelength. Sir, this is very 2014, sir. So don't think that you will get all big problems. No, you may not get all big problems. You will get this kind of problems also, which can be solved by any student. And here comes the third point. What he's saying is, a stationary state is determined by the condition that the angular moment of an electron is, that is angular moment MVR is equal to be integral multiple of h by 2 pi. So MVR is going to be n into h by 2 pi. MVR is going to be n into h by 2 pi. So we have we have tried to derive the expression for energy of the electron. This is going to be minus m into e power 4 by 8 epsilon square h square into 1 by n square. That is, you can see W is going to be minus 13.6 by n square. Minus 13.6 by n square into EV. This is very much important. Very important. Okay, energy of electron is directly inversely proportional to 1 by n square. What is the n is our orbit number. So when the n value is increasing, energy value also increases. That is, when the electron is moving away from the nucleus, its energy also increases. So this is all what we discussed. So we will discuss the remaining in the next class. So I think it's already a good time. So we will all these things we will discuss. And today's my favorite quote is, this is what I want to discuss again, sir. Success doesn't come to you, you go to it. By sitting just at home and thinking that I have to crack the gate. So the first thing is you need patience. You need patience. Listen everybody, you need patience. Definitely you need a lot of patience to achieve something. So you have to listen to the classes. You have to listen to the classes. Then only you'll be successful. You'll be successful. So the success doesn't come to you. You go to it. It means you have to work towards you. Simply sitting at home and thinking that I'll get a gate rank, I'll get gate rank. No, you'll not get it. You'll not get it, sir. You'll not get it. Definitely you'll not get it. So what you have to do, sir? You have to work hard. When you have started working hard, you will try to reach the goal. You will try to reach the goal. So success doesn't come to you. So success doesn't come to you. You should go to it. So remember, this is very important, sir. Work hard daily. As yesterday I told you, a small steps every day makes a big results. Right? Slowly, with lot of patience, you start working. Slowly, with lot of patience, you start working. Then success will definitely come to you. Success will definitely come to you. Clear? Yeah, Harish. So now we have again. So you have we have different YouTube channels for Triple E, ECE and instrumentation. We have Creatrix Gate, Unacademy Gate for mechanical and other courses, and you have Unacademy Gate for civil engineering. You have another channel called Unacademy Telugu. So as AICT is insisting every student to learn their graduation in Telugu, so probably we will reach to this Unacademy Gate Telugu, and then Unacademy SSC, and you have Unacademy Computer Science. You have Unacademy Gate questions, separate gate questions you should practice. So you have electrical junction. You have Unacademy Engineering Foundation, and Engineering Pathshala. These are the different YouTube channels which you have. These are the India's #1 study channels. Most of the students who are trying to attempt GATE are following this. So I request you to subscribe. All of you subscribe to this. Okay, subscribe to these channels. Clear? And all the classes which we have discussed, the notes will be available in this Telegram channel. You just subscribe for this Telegram channel. Correct, Pepsi. Yes, 2 hours daily we need to prepare separately GATE exam. Yes. Slowly everything happens, sir. Now when you are listening to the class, you may feel bored. But patience is required. Sir. Without patience, you can't do anything. Patience is required. Okay, coming back to this slide. So you register here. All the notes will be available in this Telegram channel. Many people have registered for many other Telegram channels, right? You will get some cinemas and everything, right? So, but for benefit of you, this Creatrix Gate EE is a group you should join. Okay, you should join. And here comes referral code SVS is equal to 10. SVS 10. So for to get 10% discount. For 10% discount. Yes, Sai Charan. It is correct. Yes, it is for both. It is for both EC. Actually, these concepts are all for EC only. My more focus is on EC students only. So this is for you only. This is for you guys only. Okay. So if you want to buy subscription. By subscription, get SVS 10 and get 10% off. 10% off on these things. So hope you understand this. So if you have any doubts, please comment on the video after listening to the class. If you have done some doubts, so I will refer and I will answer. So that's all for the day. So thank you for joining me on this Unacademy platform and YouTube live YouTube classes. Thank you all. Thank you for your lot of patience and listening. So yes, I'm teaching very slowly because many people are requested me to teach slowly. Those who are in second year, they may not understand quickly. Those who are in third year and final year, they may be listening for a second time or third time. So because of that, they might be getting bored. But initially, sir, we will go very slowly for these classes. Later on, once we start studying other subjects, I mean other concept. Semiconductor physics is very basic. That is the reason why I am teaching very slowly. Clear? That is the reason why I am teaching slowly. Okay, bye. Good night. Thank you all. Right? We'll catch up tomorrow.